Okay, I hope I'm audible to all my students who are attending this particular practice lecture for Intermediate Microeconomics Part 1 course. In this particular practice lecture, we are going to solve some selected numerical problems from the book A Short Course in Intermediate Microeconomics by Feldman and Serrano. So that is a very important book for intermediate microeconomics, and we are going to solve a couple of back problems in this lecture from this particular book. So let's quickly start with this particular lecture. So I hope all students who are attending this lecture can now see my whiteboard. So let's quickly look at problems from chapter 2 of Serrano and Feldman. A short course in intermediate microeconomics. So I'm going to focus on the numerical problems. Okay. Chapter 2 is all to do with preferences and utility. So if you have this book, let's quickly look at some of the problems, numerical problems from chapter 2 of this particular book. Okay, so let's look at the first problem. Okay, for each of the following utility functions, for each of the following utility functions, find the marginal rate of substitution, MRS. So we are given the first utility function u as a function of x1, x2 is x1 times x2. Now this is a Cobb-Douglas utility function, if students can recall from my theoretical lectures on consumer preferences and utility module. Okay, how do we find the MRS? MRS is nothing but minus mu1 over mu2. What is mu1? Marginal utility of good one. How do we find it? Partial derivative of the utility function with respect to x1. If I partially differentiate this with respect to x1, I get x2. What is mu2? It's the partial derivative of the utility function with respect to x2. When I partially differentiate the utility function with respect to x2, what do I get? x1. So therefore, my MRS is minus mu1 is x2 and mu2 is x1. So this is my MRS for part A. Okay, I hope students have understood this. Let's look at part B. So I'm erasing all this off. Question 1, part B. Again, we need to find the MRS of this particular utility function. So the utility is only coming from x2. That means in this case, x1 is a neutral good, because x1 is neither giving the consumer satisfaction nor dissatisfaction. That means x1 is a neutral good. The utility just depends on, it only depends on x2. Okay, so how do I find MRS? Again, very simple, minus mu1 over mu. So if I look at mu1, that's del u by del x1, but there is no x1 in my utility function, so del u by del x1 is 0. What is mu2? Del u by del x2. If I partially differentiate the utility function with respect to x2, I get 2. My MRS will be minus del u by del x1 is 0. mu2, which is del u by del x2, is 2. Answer is 0. For part C, we are given the utility function u as a function of x1, x2 as x1 plus x2. What type of a utility function is this? It denotes perfect substitutes. We have covered all this in our theoretical lectures on preferences and utility. Okay, how do I find the MRS? Again, it's the same thing, minus mu1 by mu2. Quickly, let's find mu1, that's del u by del x1. The partial derivative of the ut function with respect to x1 is 1. mu2 is del u by del x2. The partial derivative of the ut function with respect to x2 is again 1. MRS is minus 1 by 1, which is minus 1. This is the answer for part C. So I hope students have understood this. Let's quickly move to question 1, part D. Utility as a function of x1, x2 is min of x1 comma 2x2. What type of a utility function is this? Perfect complements. Two goods are said to be perfect complements if they are consumed in a fixed ratio. Okay, now if I have to find the MRS, I have cases here because it depends on whether x1 is more than 2x2 or less than 2x2. For a min function, you always have cases. So let's take case 1. If x1 is less than 2x2, then u as a function of x1, x2 will be what? If out of x1 and 2x2, x1 is less than 2x2, then the min of x1 comma 2x2 will be x1 only. So this is just x1 because minimum means minimum of the two. Between x1 and 2x2, we are saying that x1 is less than 2x2. We are taking that case. That means the minimum of the two is x1. Now, how do I find MRS? Same formula, minus mu1 by mu. What is mu1? Del u by del x1, which is 1. The partial derivative of x1 with respect to itself is 1. What is mu2? Del u by del x2, which is 0, because there is no x2 in the utility function right now. If you look at this utility function for case 1, there is no x2. The partial derivative is 0. So what is my MRS? Minus 1 by 0, which is infinite. MRS in this particular case is minus 1 by 0, which is infinite. Okay, so you can actually say minus infinity also, but it's fine. My MRS in absolute terms is infinite. So if I have to find mod of MRS, basically mod of MRS will be infinity. Absolute value of the MRS, if I say. The absolute value of the MRS is infinite. Okay, so I hope all students have understood this particular case. Let's look at now the next case, case 2. If x1 is more than 2x2, in that case, my utility function is going to be, now what's the min of x1 comma 2x2? Now for this case, now x1 is more than 2x2. That means the minimum out of x1 and 2x2 is 2x2. So my utility function is 2x2. Again, let's find the MRS. In absolute terms, I can say, so in general, remember students, in general, the formula for MRS is minus mu1 by mu2 only. But in absolute terms, if I take the mod value, a mod of MRS is mu1 by mu2. mu1 is del u by del x1. mu2 is del u by del x2. For this particular utility function, del u by del x1 is 0 because there is no x1 in this utility function. Del u by del x2 is 2. So my answer is 0 by 2, which is 0. So guys, in part D also, my MRS in general was minus infinity. But I am looking at the absolute value of it. Similarly, here also, MRS is 0. And the absolute value is also 0. Okay, well, we look at the absolute number of MRS. So I hope that students have understood this. Then let's look at question 1, part E. So, erasing all this off. We are again given the utility function as x2 minus x1 square. Okay, so if I have to find MRS, how do I find that? It's again minus mu1 by mu2. What is mu1? Del u by del x1. How much is del u by del x1? If I partially differentiate this with respect to x1, I get minus 2x1. mu2 will be del u by del x2. If I partially differentiate the utility function with respect to x2, I get 1. My MRS is minus, mu1 is minus 2x1, mu2 is 1, my answer is 2x1. That means in this case, my indifference curve is upward sloping. You can clearly see that x2 in this case is a good and x1 is a bad. That means more consumption of x1 is reducing your utility. It's a bad. That's why it's having a negative sign. So when you have when one of the goods, when one of the commodities is a good and the other is a bad, indifference curves are always upward sloping. Okay, so I hope students have understood how we have calculated the MRS. Now let's look at the back problems. So I'm erasing all this off now. Okay, let's come to the back problem. So all students can see the back exercise. This is the exercise for chapter 2. Okay, Serrano and Feldman. Okay, so let's look at the back problems now. So let's look at the first back problem. We assumed at the beginning of the chapter that a consumer's preferences must be transitive. Okay, now let's look at the following cases to check whether these are transitive or not. So part a consumer likes sugar in her coffee, but she simply cannot taste the difference between a cup of coffee with n grams of sugar and a cup of coffee with n plus 1 grams. Okay, you like sugar in your coffee. That means the more grams of sugar you have, the better. But your tongue cannot distinguish between the taste with n grams of sugar and the taste with n plus 1 grams. That means suppose someone puts 5 grams of sugar in my cup and someone puts 6 grams of sugar, then my tongue cannot tell the difference between 5 and 6 grams. Now suppose a teaspoon of sugar is 6 grams and suppose she takes her coffee with 1 teaspoon of sugar. Why does this violate transitivity? Okay, so if I put 6 grams of, if I take 1 teaspoon of sugar, which contains 6 grams, why is it violating the transitivity? Okay, now it's violating the transitivity because if I come to the whiteboard to explain, so now these are the back problems. I'm writing them for completeness. Back problems, chapter 2, Serrano and Feldman. So we are looking at problem number 1. Okay. Now understand this. We are given that 1 teaspoon of sugar, 1 teaspoon of sugar contains 6 grams. 1 teaspoon of sugar contains 6 grams of sugar. Okay. Now, if I don't have this teaspoon at all, that's 0 grams, I am indifferent between 0 gram and 1 gram. Because in the question we were given that the consumer is indifferent between n grams and n plus 1 grams. So I am indifferent between 0 and 1 gram. I am indifferent between 1 gram and 2 grams. I am indifferent between 2 gram and 3, 3 and 4, 4 and 5, 5 and 6. Okay, if I am indifferent between 0 and 1 gram, 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, by transitivity, I should be indifferent between 0 and 6 grams also. So by transitivity, the consumer should be indifferent between 0 and 6 grams, where all this is in grams, 0 gram. So I'm saying that we are given that the consumer is indifferent between n grams and n plus 1 grams. That means the consumer is indifferent between 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6. Okay. These tell us that the consumer is indifferent between 4 and 6. Okay. This tells us that if the consumer is indifferent between 3 and 4 and 4 and 6, the consumer is indifferent between 3 and 6. If the consumer is indifferent between 2 and 3 and 3 and 6, the consumer is indifferent between 2 and 6 also. If the consumer is indifferent between 1 and 2 and 2 and 6, the consumer is indifferent between 1 and 6 also. And if the consumer is indifferent between 0 and 1 and 1 and 6, the consumer is indifferent between 0 and 6 also. By transitivity, the consumer should be indifferent between 0 and 6. So I can say this means that the consumer should be indifferent. The consumer should be indifferent between 0 grams of sugar and 6 grams of sugar. The consumer should be indifferent between them. But like we said that, but 0 grams of sugar corresponds to no teaspoon and 6 grams of sugar corresponds to 1 teaspoon. Because in the beginning, we were given that 1 teaspoon contains 6 grams of sugar. So 6 grams of sugar corresponds to 1 teaspoon. And in the beginning of the question, we were given that the consumer likes more teaspoons of sugar. See, a consumer likes sugar in her coffee. She likes more teaspoons of sugar. So I can write, since consumer likes to have sugar in her coffee, therefore, for this consumer, 1 teaspoon of sugar gives her more satisfaction or more utility than 0 teaspoons of sugar. 1 teaspoon of sugar contains 6 grams. It should give more satisfaction than 0 teaspoon of sugar, which contains 0 grams. So are we arriving at a contradiction? Yes, look at this. By transitivity, the consumer should be indifferent between 0 and 6 grams. But in the beginning of the question, we were given that the consumer likes to have sugar in her coffee. That means for this consumer, 1 teaspoon of sugar should give more satisfaction than 0 teaspoon of sugar. 1 teaspoon of sugar contains 6 grams. 0 teaspoon of sugar contains 0 grams. For this consumer, 6 should be preferred over 0. But by transitivity, consumer should be indifferent. So therefore, we have arrived at a contradiction. We have arrived at a contradiction, therefore violates transitivity. The preference violates transitivity. Because on one hand, we are saying that the consumer likes to have more sugar in her coffee. So 1 teaspoon of sugar is better than 0 teaspoon of sugar. 1 teaspoon of sugar, 6 grams, 0 teaspoon of sugar, 0 grams. 6 should be preferred over 0. But then at the same time, we are saying that the consumer is indifferent between n and n plus 1 grams. That means the consumer is indifferent between all these. 4, 5 and 5, 6 by transitivity correspond to 4, 6. 3, 4 and 4, 6 correspond to 3, 6 by transitivity. 2, 3 and 3, 6 correspond to 2, 6 by transitivity. 1, 2 and 2, 6 correspond to 1, 6 by transitivity. 0, 1 and 1, 6 correspond to 0, 6 by transitivity. By transitivity, you should be indifferent between 0 and 6 grams. But then you are saying that you prefer 6 over 0 grams. You have contradicted yourself. Transitivity axiom is violated. Okay, and then let's look at part B to this problem. So I hope all students have understood this. Let me come to part B. So if I come back to the question paper, if I come back to the back problems, let's call a committee of 3 people a consumer. Our committee takes decisions using majority voting. When the committee members compare two alternatives X and Y, they simply take a vote and the winner is said to be preferred by the committee to the loser. Now, suppose the preferences of the individuals are as follows. Now, I can write it here only. The solution. Person 1, person 2, person 3. For person 1, X is the best, Y is the second best alternative, Z is the third best. For consumer 2, Y is preferred over Z is preferred over X. And for person 3, Z is preferred over X is preferred over Y. Now I need to show whether it's violating transitivity or not. Now guys, if I go by majority, one also prefers X over Y. Okay, one also prefers X over Y. And Z also prefers, sorry, 3 also prefers X over Y. For individual 3 also, X is preferred over Y. So I can say, therefore, by majority, there are 3 people. 2 are preferring X over Y. They rank X ahead of Y. So by majority, I can say that X is preferred over Y. Now let's look at Y and Z. For person 1 also, Y is preferred over Z. And for person 2 also, Y is preferred over Z. So by majority, Y is preferred over Z. Now, if X is preferred to Y and Y is preferred to Z, transitivity says that X should be preferred to Z. So I can say, according to transitivity, X should be preferred to Z. But is it happening? No. Look at individual 1. Only individual 1 prefers X over Z. If you look at 2, individual 2 prefers Z over X. You can see Z comes over X. Individual 3 also prefers Z over X. So by majority, individuals 2 and 3 are preferring Z over X, so Z should be preferred. So transitivity is violated because if you go by this order, majority prefer X to Y, majority prefer Y to Z. By transitivity, X should be preferred to Z, but it's not. Individual 2 also you can see prefers Z over X. Individual 3 also you can see prefers Z over X. So therefore transitivity is violated. Because if you go by majority voting, alternative Z should be preferred to X. But if you go by transitivity, X should be preferred to Z. So I can say therefore transitivity is violated. Transitivity is violated. So I haven't come to the whiteboard. I've solved this question here. Okay. So I stop in this particular lecture. In the next lecture, I'm going to start my discussion from problem number 2 from chapter 2 of Serrano&Feldman. So I hope all students have enjoyed this practice lecture. Any doubts in this lecture, you can unmute your mics and ask, or you can get in touch with me on call or WhatsApp, or you can drop me a mail with your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.